Hello, this is the second video for section 5.2. In this video we're going to look at how do you graph polynomial functions. Okay, so in order to graph polynomial functions we have to look at what's called the end behavior. So what the end behavior is the way the graph goes as x approaches positive and negative infinity. So as x gets really big or really small. Okay, so basically we're looking at what happens on the right side of the graph and the left side of the graph. For polynomial functions, either the graph is going to increase towards infinity or decrease. It's not just going to stop. Okay. End behavior depends on the degree and the leading coefficient. Okay, so that's what's going to tell us what the end behavior is. So basically, whether the degree is even or odd, and whether the leading coefficient is positive or negative. Okay, so think about it. If I have an even degree, so what's a simple polynomial with an even degree? The simplest one would be y equals x squared. Y equals x squared, we know what that graph looks like. It just looks like this. Okay, so what do the ends of the graph do? Well, they keep getting bigger, and as the negatives also keep getting bigger. As I plug bigger negative numbers in here, when I square it, it becomes positive. So the ends get bigger. Okay. What if I did a different even degree, like y equals x to the fourth? Okay. If I was to plug huge numbers in there and take them to the fourth power, the numbers are going to keep increasing to the right side. If I plug big negative numbers in there and I take it to an even power, it's going to create a bigger positive number. So the ends are going to continue to increase. Okay, so that's going to be the shape of those if I have an even exponent. Okay, if I have an odd exponent, however, like y equals x cubed, what happens then? Well, when I plug bigger positive numbers in there and I cube them, they're going to continue to increase. However, if I plug negative numbers in, when I take a negative number and take it to an odd exponent, it gives me a bigger negative number. So these graphs are going to look something like this. So the right side is increasing, but the left side is going towards negative infinity. Okay, so even exponents, both ends are increasing, and odd, the positive end is increasing, the negative end is decreasing. Now what's the leading coefficient going to do? Well, what happens if I put a negative number in front of the x squared? Remember what happens? It flips that graph. Okay, so now if I was to graph y equals negative x squared, it's going to flip that graph, so both ends are going to be pointing down. Okay, same thing if I put a negative number in front of an x cubed, it's going to flip that graph and it's going to make it look something like this. Okay, so the right side is going to decrease and the left side will increase. Okay, so in general, on page 339 in your book is a summary of this. I've also written it down here. It's a little bit of a mess, but let's go through that. So if my degree is even and my leading coefficient is positive, so if I have something basically like y equals x squared or y equals x to the fourth, it's going to, the general shape is going to look like this. The ends are going to increase. The middle, we don't know what the middle does. Depends on the equation. Okay, but all we know is that the ends increase. So this is how they write it in their book, and this notation is a little confusing for sometimes. The way you read this is f of x approaches infinity as x approaches infinity, and f of x approaches infinity as x approaches negative infinity. All that is saying is, sometimes reading it backwards is better. When x gets bigger, as my x values increase, my function increasing goes to positive infinity. As x values decrease, so we go into the negatives, my function values increase as well. Okay, so that's if I have even and positive. If I have an even degree and a negative coefficient, remember it flips that graph. So my function approaches negative infinity as x approaches infinity. So as x gets bigger, my function values approach negative infinity. As f of x approaches negative infinity as x approaches negative infinity on the left end as well. Okay? If I have an odd degree and a positive coefficient, we know that like y equals x cubed, it's going to look something like this. So the function approaches infinity as x approaches infinity. So as x gets bigger, this way, my function increases. My function decreases as x approaches negative infinity on the left side of the graph. Okay, and then an odd and a negative. My function approaches negative infinity because this one's flipped as x approaches infinity. So as x approaches infinity, my function decreases, approaches negative infinity. As my function approaches infinity, as x goes into the negatives, negative infinity. It's a little confusing with the terminology, but basically we're trying to figure out what's going on here. What is the function doing as x approaches positive or negative infinity? Okay, so let's just do a couple quick examples here. So we got the first one right here, negative 3x to the 4 plus 2x squared minus 3. So we need to know what the degree and the leading coefficient are. So my degree is even, my leading coefficient is negative. So we have this situation here. So a sketch of this graph would be something like this. Okay, we know the ends decrease like that. We don't know what happens in the middle. Could be anything. But we're just trying to predict the end behavior. So if I was to fill this in and put either positive or negative infinity, in this case, because I know the degree is even and I have a negative, makes both ends go down, so my function approaches negative infinity as x approaches infinity, and it approaches negative infinity as x approaches negative infinity. Both ends are going down. Okay, so see if you can fill in the blanks for these two real quickly. Pause the video, try it, and then tell you what the answers are. Okay, so on this one we have an odd with a positive. Okay, so a lot of times it's easy to make a quick sketch. So odd and positive. Odd means the ends go in opposite directions. Positive means the right side's going up, the left side's going down. Okay, so my function approaches what as x gets bigger? It approaches infinity, goes up. My function goes where as x approaches negative infinity? Goes down. Okay. This one we have an odd with a negative. Okay. So that's the same as this one, only where the graph gets flipped. So it looks something like that. So as x approaches infinity, my graph is going towards negative infinity. And this one, as x approaches negative infinity, my function approaches infinity. Okay, so that's how we interpret end behavior. Now, how do we actually graph? Well, get our sheet of graph paper. And let's graph this one. Okay, so what we're going to do is, the first thing we're going to do is we're going to predict our end behavior, and we're going to make a quick sketch of the graph. Okay, so we have an odd with a negative. Okay, so if it's odd and negative, we know in general the graph is going to have a certain shape. Odd means they're opposite directions. Negative coefficient means the right side's going down and the left side's going up. So it looks something like that. Okay? Now, that all we know is that the ends. We don't know what happens in the middle. So what we need to do then is just plug some values in, make a table, and plot the points. Okay? So Make a table. So I'm going to go from, say, -2 to 2. And what we're going to do is we know how the ends behave, so we may have to extend this graph to bigger negative numbers or bigger positive numbers, depending on what kind of values we get. So when I plug -2 in, let's see what I get. Now be careful with this negative. Remember, we have to cube and then multiply by -1. So in this case, I'll have -2 cubed, -2 squared, -2. So this is going to be -8 times that is +8. This is going to be +4. This is -2 and -1. So 12, 10, 12, 9. This looks like it gives me 9. Okay. Alright. Yep. So that's 9. Plug -1 in there. Let's see what we get for -1. So -1 cubed is -1 times that's going to give me 1 plus 1 minus 1 minus 1. Looks like I get 0. Okay. 0 is easy because I get 0 plus 0 plus 0 minus 1 is -1. Plug in 1. So 1 squared is 1, or 1 cubed is 1. So that gives me -1 plus 1 plus 1 minus 1. So that gives me 0 as well. And then 2 cubed is 8. So that's -8 plus 4 plus 2 minus 1, 8, 6, so that's -3. Okay, so let's start by plotting those points. There, so that's -2, 9, -1, 0, 0, -1, 1, 0, and 2, -3. Okay, so now we look at our points. We know our graph is some shape like this, so if I follow this through here, it looks like it kind of does that. Graph. Now, do I need to try numbers like -3, -4, or can I be sure that it continues to increase? Well, because this went from 0 to 9, if I try -3, I'm going to get a bigger number. It's going to keep increasing because I know what the end behavior does. Same thing on this side. This graph came down, came back up, went back down. Because we know the end behavior, we know it's going to continue in that direction. Okay. Now, if we wanted to be a little more accurate, we could try some more points in between here to see, like, how do I know whether this graph comes up here higher or if it just comes to here and down? I could try like 1.5 or 0.5 as values as well to get a little more accurate. But as long as I have these points in the middle, I can get the general shape of this graph. And that looks pretty good. So that's how we graph these. Basically, we look at end behavior, we make a table, and we plot those as many points as we can to get the general shape of the graph.